Hi, this is John Keller from the University of Alaska in Fairbanks. This is a video explaining how to do part one of exploring molecular geometry and bonding for the Chem 105 lab. I'm using nitrogen trifluoride as an example. Start by going to the WebMO.net website that has the demo page that you would use for the calculations. Log in as guest. This is the job manager and shows all the previous jobs. Note there have been over 1 million jobs submitted from around the world at this website. Start with a new job, create new job. This gives a blank workspace where you can build your molecule. We start with a build tool, and let's put our atoms in. We'll start with a nitrogen, touching in on the keyboard, and left clicking puts the nitrogen there. Now we need some fluorine. Okay, put in 3 fluorine atoms. Now, using the rotate tool, you can see that what we've built, you see, is flat because it was created on the workspace. Now let's use the cleanup tool, which applies an approximate VSEPR theory to the molecule. You see now, you can see it's non-planar. And we can use the adjust tool to check some of the bond distances. These results are shown on the bottom left of your screen. Or you can check bond angles. Okay, this is our input molecule. Now let's start a calculation by hitting the continue button. And there's a variety of programs there. We are going to use the standard program called Gaussian. Hit continue. Include your initials so that you can find this later on that long list. We're going to do a molecular energy calculation. Hartree-Fock theory is one way to solve the Schrödinger equation. The basis set is these different sets of atomic orbitals that are used. Both of these are explained briefly on the handout. The charge of this is 0. It's a molecule, neutral, and it's has a singlet multiplicity. That means all the electrons, all the valence electrons, are in orbitals, 2 electrons per orbital with their spins paired. All right, now click continue to submit the job. Click the job name when the job is done, and notice that it's has the same geometry. We just did a energy calculation, did not change the geometry. And down here on the calculated quantities, you see the energy. This is called restricted Hartree-Fock energy. Restricted refers to the singlet state that we specified in the input file. The energy is minus 352.4739 Hartrees. This is a very large negative number because this represents the energy difference between the molecule and the constituent particles, that is 4 nuclei and 34 electrons. Okay, now we can log out. Go back to the job manager. Log out.